Good morning to all. In today's class, we will discuss polymorphism and inheritance. These two concepts are very, very important in Java. Polymorphism and inheritance. First, we will complete compile time polymorphism. Already I discussed constructor overloading in the last class. Now we will discuss method of overloading. After that, we will go to inheritance. So in inheritance, we will discuss overriding concept. Overriding is runtime polymorphism and overloading is compile time polymorphism. Okay. So explain about polymorphism means first draw this structure, that is in polymorphism we have two types, compile time polymorphism and runtime polymorphism. If the polymorphism occurs during the compile time, then it is called compile time polymorphism. So overloading comes under compile time polymorphism. If you take runtime polymorphism, if the polymorphism occurs during the runtime, then it is called runtime polymorphism. Overriding comes under runtime polymorphism. But without inheritance, I can't explain overriding concept. That's why first we will start inheritance. After that we will discuss overriding. So overriding comes under runtime polymorphism. Okay. See, in the same way, overloading comes under compile time polymorphism. So again, if you take overloading concept, it is of two types: constructor overloading and method overloading. So already we discussed constructor overloading. So what is constructor overloading? Two or more constructors having the same name, and they may differ either in the number of arguments or type of arguments or order of arguments. Then in this case, the constructors are said to be overloaded constructors. In place of constructor, if you write method, then it is method overloading. Okay. So already we completed program on constructor overloading. So this is the best example to explain constructor overloading. So here in this class, student, I have taken three constructors. This is student no-arg constructor, that is user-defined no-arg constructor. Next, user-defined parameterized constructor with three parameters. Next, third constructor is, it is also user-defined parameterized constructor, but it is having only one parameter. So in this student class, I have taken three constructors. Okay. So this is constructor 1, this is constructor 2, and this is constructor 3. In any class, if you write more than one constructor, then the concept comes under constructor overloading. More than one, remember. Minimum 2 must be there to explain the concept of constructor overloading. So here, this is the best example program to explain the constructor overloading concept. After writing three constructors, how to invoke those three constructors is using these three statements. Whenever you create an object, at that time only the constructor of that class will be invoked. So here this will invoke no-arg constructor. This will invoke this constructor with three parameters, and this student of S1 will invoke the third constructor, that is constructor with one parameter, but here the parameter is an object. That's why we are sending the reference variable, that is address of student object to this student. So this S1 is address is copied into OBJ. Now the statement is student OBJ is equal to S1. Means both OBJ and S1 are pointing to the same object. So here what we are doing using this constructor is, we are copying the contents of the first object into third object. Okay. This is the third constructor. So this is the best example for constructor overloading. Similarly, you can write the constructor overloading program on your own by taking two or more constructors. Now we will see method overloading. So here what is method overloading? Two or more methods having the same name, and they may differ either in the number of arguments or type of arguments or order of arguments. But here one more point to be added is, but not on the return type, because constructors do not have return type. That's why in constructor overloading, there is no sentence like this, but not on the return type, because methods must have return type. That's why we have to consider return type also. Okay, but what is the statement on return type? But not on the return type. See, I will repeat once again. Two or more methods having the same name, which may differ either in the number of arguments or type of arguments or order of arguments, but not on the return type. Means don't consider the return type to explain method overloading concept. Means consider only parameters to explain method overloading. Means don't consider return type. Okay, return type may be same or may not be same for the methods. Okay, that's why here while explaining the concept method overloading, so consider only parameters, don't consider return type. Now we will see the examples on method overloading. Okay, so here this is class test. Inside the class test I have written two methods. What are the two methods? Sum. See, two or more methods having the same name, but they differ either in the number of parameters or type of parameters or order of parameters, but not on the return type. So return type may be same or may not be same. Remember this point. Now we will check whether here in this example, whether the method is called overloaded method or not. How do we check? Only based on the parameters. So here this method is taking two parameters. This method is also taking two parameters with the same name. Okay. When it is taking the same number of parameters, see the type of parameters. Here the order is int float. Here the order is float int. Means in this case we can say that the method sum is overloaded or overloaded method. Okay. Now here two parameters. If the number of parameters is same, check whether either order or type. See, if you see the order int float int. So here, but don't see the return type. Return type may be for both methods, void or void int or int void. It can be anything. Don't see the return type. Okay, forget about return type. Only see the parameters. Like constructor overloading only. Because we are explaining constructor overloading and method overloading in the same way, That's why constructors do not have return type, That's why while considering method overloading also, don't consider return type. Only consider on the parameters. Means check the parameters. And next, if you take one more example, now again here I have written methods, two methods that is with the same name, sum. And now I will check whether it is overloaded function or not. So here this sum is taking one parameter. Here it is also taking one parameter. Then I will check the type. If both the methods are having the same number of parameters, then check the type. Now here it is int, here it is also int. Okay. So in this case, this method or function sum is not overloaded method, because it is taking the same number of parameters and the type of the parameter also same in both these two functions. So but don't see the return type. If you observe the return types are different now. But we are not considering the return type while explaining method overloading. That's why don't see that return type. Now in this case, in this example, the method sum is not overloaded. So how to modify this? Here it is int, You take here it as float or double or any data type you can take other than int. Okay, in that case, this sum is said to be overloaded. Like that, the compiler will check whether the method is overloaded or not. Okay, based on the definition. So what is the definition of method overloading is two or more methods are having the same name and may differ either in the number of parameters or type of parameters or order of parameters, but not on the return type. The compiler will check as per that rule. So if it checks as per that rule, it will find that here in this case the sum method is not overloaded. Okay. Now we will write one program on method overloading. This is the simple program. Here I am taking the method name as sum. So here we have to change the parameters. So here in this sum I am taking 2 parameters. Here I am taking 3 parameters. Next here I am taking 4 parameters. But the purpose of all these 3 methods is to find the sum. That's why I am taking the same name for all these 3 methods. So 2 or more methods having the same name up to that. Okay. Next I will check the parameters. Here it is 2 parameters. Here it is having 3 parameters. Here this method is having 4 parameters. Means here these 3 methods are differing by number of parameters 2, 3 and 4. Don't see the return type. So in this case, here we are having 3 methods with the same name and they are differing by the number of parameters. So in this case I can say the method sum is said to be overloaded. Okay, don't see the return type. Now we will see the flow of this program. So here in this I am adding 2 integers. Here you can take one as int and another one as float. Next, if you take the same number of parameters, change the order. Here float, here int. Like that, if you take the same number of parameters in 2 or more functions, change the type of the parameters. Okay. Now here I will explain the flow of this program. Here this method is calculating sum of 2 integers. This method is calculating sum of 3 integers. And this method is calculating sum of 4 integers. That's why in this case, the method sum is said to be overloaded. That's it. So inside the overload demo class, here the name of the class is overload demo. In this class I have written 3 functions. Means if you observe this class, when you want to describe this class with respect to state and behavior parts, here this class does not contain state part. See, there are no instance variables in this class. There are no instance variables or static variables in this class. That's why here this class does not contain state part. It consists of only behavior part. And how many methods are there under behavior part? 3 methods. Okay, like that you can describe each and every class with respect to state and behavior part. After that, how do I access the members of this overload demo? To access the members of this class, I need to create the object for this class. So the objects can be created within in the main method of the same class or in the main method of another class. So here I am taking one more class to write the main method. The class name is test. Inside this I have written main method. Inside that I am creating the object for that previous class, that is overload demo. Because I want to access the sum function of that class, that is overload demo. That's why I have to create the object for that class. So how do I create object for that class? Overload demo O1 is equal to new overload demo. Okay, this is the object creation for overload demo class. So from this statement, if you execute this program Java test, then the JVM will invoke main method. After that it will execute this statement. So whenever this statement is executed, one object is created in the memory for overload demo. And inside that object, instance variables are stored. But for this class overload demo, there are no instance variables. That's why what will happen in the memory is only object is created, means with no instance variables. That's why it is called empty object, because instance variables are not there for overload demo class. So even though it is empty object, it is having some address, and the address of this empty object is stored in the variable O1. Means O1 is pointing to the empty object. Next, after that, with this reference variable O1, we can access the members of this overload demo class. That is, these are the members of this class. Here members are nothing but 3 methods. Okay. Now I will access the members of that class using O1. How do I access? Using invocation of that method. These are called method definitions. This is the definition of this sum function with 2 parameters. Definition means body must be there. That is open brace, closing brace. This is nothing but body. Inside the body of this method, I will write the functionality of this method. What is the functionality of this method sum is? It is calculating the sum of 2 numbers and storing in one variable, and it is printing that sum as output. Okay, like that. That class consists of 3 methods. How do I access the methods of that class is by creating object like this. Without creating object for overload demo class, it is not possible to access the members of that class. That's why whenever you want to access the members of the class, we need to create object for that class. Okay, this is must. Whenever this statement is executed, always the constructor of that class is executed. If you won't write the constructor in overload demo class, the compiler will provide default constructor which will assign default values for all the instance variables based on the data type. But here there are no instance variables in the overload demo class. That's why only empty object is created. The address of that object is stored in O1. Now with this O1, I will access the sum function of overload demo class. So this is here O1 dot sum of. Here I am sending two values to the first method. Because that method is taking two parameters. Similarly, this is the second method invocation. That is O1 dot sum of three integers. Third method invocation is here. O1 dot sum of four integers. Like that, this is called invocation of the third method. This is called invocation of second method. This is called invocation of first method. So whenever this statement is executed by JVM, from this it will go to the overload demo class, because this is the reference variable for overload demo object. That's why on the first object, means on this object, here it is only one object. No? On that object I am invoking sum of 10, 20. From that the control goes to this statement. Matching method. This is the matching method for that invocation. That's why A is holding 10 and B is holding 20. So inside this method, what I am doing is I am adding these two 10 plus 20 and it is stored in this variable C. Now I am printing this C value, means the output is here 20. Similarly, the second invocation will invoke this method. Here it is returning something. So that return value will be stored in one variable. See, this is second method invocation, O1 dot sum of 10, 20, 20, 20, 30. After finding the sum in that method, it is returning the sum, that is 60. That 60 is stored in this variable X. I am printing that X value. Next, if you take the third method invocation, inside the system.out.println, means inside the printf statement also we can invoke the sum function like this. Means O1 dot sum of 10, 20, 30 means it will go to that third method and it will calculate 10 the sum of four values, and it will return that value, and that return value will be stored here. Means you will get the answer is 70, 90, 100. So you will get this statement will give you 100 as output. So finally, if you execute this program, the output is 30, next 60 and 100. So this is the program on method overloading. So two or more methods having the same name, and they may differ either in the number of parameters or order of parameters or type of parameters, but not on the return type. Okay. Now you may get one question, that is what is the exact real-time application for method overloading? Okay. So where we use exactly in real time is, suppose let us take the example for area. So in mathematics, you know, we can find the area of a sphere, area of a circle, area of a triangle, area of a square, area of a rectangle. See, if you observe all these, the name is same, no? Name is area, but functionality is different, no? Area of circle you will get by using some formula you will get the value. So formulas for all these are different, means functionality is different for each one. That's why when you want to find area for circle, sphere, square and rectangle, you can use this. How do we write the program for calculating area of all those is by using method overloading. That is the exact real-time application. This is also real-time application only, because sometimes we can find sum of 2 integers, sum of 3 integers, sum of 4 integers. No, that's why we will use the same name. Similarly, you can take product. or you can take area. So homework is write 2 programs. One is for area and the second one is for volume. So like area we can find, we can use volume. So how do we find volume? Volume of a sphere, we can find volume of a rectangular box, we can find volume of a cube, we can find. Like that, take the formulas, volume of a sphere formula, volume of rectangular box formula, and write separate method for each one. So volume. So but take the parameters based on the formula, volume of the sphere. So inside this write the functionality. How do we find the volume of the sphere? Like that, volume of a cube. Like that, volume of a rectangular box. So 3 methods write using the same name, volume, volume, volume. But inside the functionality is using the formula. Okay, you know the formula for sphere, formula for circle, formula for volume of a rectangular box or volume of a cube. Suppose in the formula, if 2 methods are taking the same only one argument, in that case change the type of argument. Okay, suppose in two formulas you are both are taking only one parameter. In that case take only one parameter here and here, but here take the data type as int, here take the data type as float. Okay, like that write the functionality using the formulas. Like that, homework programs on method overloading is first program 1 is calculate the area for what? Square, rectangle, circle, triangle, sphere. So means 5 methods we have to take with the same name area. So in this case the area method is set to be overloaded. Next one more program is volume. So volume for we can find volume for sphere, rectangular box, cube, like that. If you find any other, you write. So for each one you take we take one method and take the same name, volume, 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 or area, area, area. But see the parameters, they must differ either in the number of parameters or order of parameters or type of parameters. So like that we can write programs on method overloading. So with this method overload, we have completed method overloading concept. Means with this we have completed both constructor overloading and method overloading concepts. Both are under compile time polymorphism. And now here I have one question. Why it is called compile time polymorphism? So the reason is that during the compile time, the compiler will check the rule for method overloading or constructor overloading. So the compiler will check here first sum, sum, sum. So here 3 methods are there with the same name. Then it will check whether they are differing by the number of parameters or type of parameters or order of parameters. Now, so here it will check that point first. When 2 or more methods are having the same name, then the compiler will check the parameters. They must be differed either by the number of parameters or order of parameters or type of parameters. When it checks here in this program, it is taking 2 parameters, 3 parameters, 4 parameters. Even though the data types are same for all these, but here these parameters are differing by the number 2, 3, 4, and it will not check the return type. So in this case, it is the correct syntax for method overloading. The compiler knows the rule for method overloading. As per that rule only it will check. So after checking, okay, the compiler will understand that here there is no error. Okay, it is method overloading. Suppose if you see the previous program, then the compiler will check these 2 methods. What the compiler will do? So here the name of the method is same. Okay, here sum means it has to check the parameters. But when it checks the parameters, here it is taking one parameter. But again it will check the type of the parameter. If both functions are taking the same number of parameters, then it will check the type or order. So here the type is int, here also type is int. So in this case, the compiler will give you compiler error. You execute this program in the lab. So this error is compiler error. Why it is compiler error means compiler knows the rule for method overloading. So as per the rule, the compiler will check these two methods. So after checking, the compiler will understand that it is not following the rule of method overloading. That's why it will give you compiler error. That's why method overloading and constructor overloading comes under compile time polymorphism. Poly means many forms. Poly means many. And now here also it will check, the compiler will check during the compilation time only. So all the three constructors are checked by the compiler during the compilation time. So here three constructors are there with the same name, no? Then in that case the compiler will check the parameters. So when it checks the parameters, here it is not taking any parameter. Next here it is taking three parameters, and here it is taking one parameter. Means all these three constructors are defined by number of parameters. So as per the rule, it is correct. That's why the compiler will not give you any error. But why it is called compile time polymorphism is the method overloading and constructor overloading. These two are checked by the compiler during the compilation time. That's why this concept comes under compile time polymorphism. Already explained, if the polymorphism occurs during the compile time. So constructor overloading and method overloading, these two are checked by the compiler during the compilation time, whether they are following the rule or not. You know the rule for these two, no? Okay. Next, when you see the runtime polymorphism in inheritance, you will get the concept of overriding. So here this overriding concept, the JVM will check during the runtime. I will explain this concept next after understanding the inheritance concepts. So with this compile time polymorphism completed. Okay. Next topic is inheritance. So polymorphism and inheritance both are very, very important in Java. Now we will see. We will start inheritance. So this is very, very important for exam point of view, and for in Java, in any object-oriented programming languages. So inheritance is very, very important. Okay. So what is the main advantage of inheritance is code reusability. Okay. So I will explain this concept code reusability in inheritance. How we are using the same code again and again without writing that code. Okay. Now I will explain first. Here actual inheritance. I will explain here. What is inheritance means, you can write this one. The process of getting variables and methods. So if you take any Java program, we will consider only variables and methods. Variables nothing but state part, and methods are nothing but behavior part. So if you take any class, whether it is simple class or complex class, even though that class consists of thousands of lines, but we can segregate that class, okay, in terms of state part and behavior part. State part is nothing but variables, behavior part is nothing but methods. Okay, so understand the class thoroughly. And now the process of getting variables and methods from one class into another class is called inheritance. With this definition, what we can understand is we have to take two classes. Means inheritance. In inheritance, we should take minimum number of classes 2. With one class, we cannot explain the concept of inheritance. That's why if you understand this definition, here it is one class, here it is another class. Means minimum number of classes we should take is 2 in inheritance. So what is the inheritance definition? The process of getting variables and methods from one class into another class is called inheritance. Okay. Next here, to get these variables and methods of one class into another class, we use the keyword extends. Okay, so we use the keywords extends in inheritance to get the variables and methods of one class into another class. Okay, this first class is called superclass and the second class is called subclass. Okay, now we will see one program first without inheritance. After that, we will write the same program with inheritance. Then you can understand the concept of code reusability in inheritance. Follow carefully, very, very important. Now, So the main advantage of inheritance is code reusability. Now I will explain this code reusability concept with respect to two programs. First program is without inheritance, and second program I will write the same program using inheritance. Then you can understand this concept code reusability. Okay. Now first program is without inheritance. Now, so here I will take class manager. Okay, the name of the class is manager. All these are real-time classes. See, class manager. So Java is mainly used for real-time applications. That's why I always take the real-time scenarios for writing Java programs. You can write the programs on your own. Don't by heart the programs, but concentrate on the concept. Once you understand the concept, you can write the programs on your own. See, I am explaining with the student class now. After understanding the student class, you can take in the same way box class you can take, and you can explain the same concept with box class or with employee class or with bank account class or with manager class. You can take any class. Okay. Now here the concept is inheritance. Now I am writing the program without inheritance. Okay. Now here the class name is manager. And if you see the naming convention is if it is only one word, the first letter of that word must be capital letter in case of class naming convention for class. Okay. Now class is a keyword, class name is an identifier, and the naming convention is if there is only one word, then the first letter of that first word must be capital letter. So that's why I have written class manager. This is the class definition. Okay, this is class definition, open brace, closing brace. So inside that manager class, what I am writing is I am writing 3 instance variables. So now I identify the instance variables. It is very, very important. If you can't understand instance variables, there is no use of writing Java programs, because inside each object of any class, only instance variables of that class will be stored. So how do we identify instance variables? Okay. So here these are defined inside the class and outside the method and not declared with static keyword. That's why these are called instance variables. They are employee ID, employee salary, and employee name. Okay. Next, after defining the instance variables, here I am writing only one method, that is get employee details. This method is nothing but like display method of student class, which will display all the values of these variables. That's it. So here, how do we describe the manager class? It consists of 3 instance variables and 1 method. That's it. Next, similarly, I will take accountant class. I will insert the same code. Means I will put the same code in accountant class also, because accountant is also an employee. That's why same instance variables, employee ID, employee salary, employee name, and the same method get employee details to print the details of each and every employee. Okay. Who is an accountant. Next, similarly, I will take one more class, attender. Okay, class attender. So write the same code. Means 3 instance variables and 1 method, that is get employee details. Right in accountant class also. So here, till now I have taken 3 classes. They are class manager, class accountant, and class attender. All the 3 classes are having the same code. Remember, okay? After that, I will take one more class, test. Inside this test class, I will write the main method. Inside the main method of test class, I will create 3 objects for each class. 1 object for manager class, 1 object for account class, and 1 object for attender class. Why do I create these objects? Is to access the members of that class. So to access the members of the manager class, we need to create object for manager class. Like that, to access the members of account class, we have to create object for account class. Next, attender class. This is attender class object. With this reference variable, I can access the members of the attender class. Okay. Inside each object, only instance variables will be stored. Okay. Now, after creating the object for manager class, I am invoking the method get employee details with this reference variable. Okay. Now I will explain this one. Now save this file as test.java. Next, compilation is javac test.java. When you compile this program, first it will go to the not here. Now when you compile this program, not now here. Here inheritance means I have to explain separately like this. So manager M1 is equal to new manager. Okay. So here when you execute this program, or when you compile this program, I will explain like this. So when you compile this program, that is Java C test.java, because main method is there in test class, that's why we must save the file as test.java. So test.java consists of how many classes? 4 classes. What are they? Manager, accountant, and attender, and test. So test.java file consists of 4 classes. Okay. So after that, when you compile this with test.java, that is Java C test.java, so all the classes of test.java are compiled. First it will compile manager class. The compiler will start compiling from manager class because it is the first class in that file. No? So when the compiler compiles this class, first it will check whether this class consists of any constructor. But here it will not find any constructor. In that case, the compiler will add default constructor to this manager class. So how it will add? Manager, no arguments, open brace, closing brace. Inside that it will assign default values for these 3 instance variables based on the data type. That is employee ID is assigned 0, employee salary is 0.0f, and ename is null. Because it is a reference variable, the default value for any reference variable is null. So here, remember carefully. Here inside the manager class, the compiler will add default constructor during the compilation time, which will assign default values for all the instance variables of that class based on the data type. You remember this statement. After that, this class is compiled by the compiler. When the compiler compiles this class, again it will check whether this class consists of any constructor. Okay, again it will not find any constructor in this class. Then in this case, again for this class, the compiler will add default constructor, that is accountant of no arg, which will assign default values to all these 3 instance variables. Next, when this class is compiled, again the compiler will add default constructor, that is attender, no arg. Inside that it will assign default values to all the 3 instance variables of attender class. Okay, like that default constructors are provided to all these 3 classes, that is manager, accountant, and attender. Similarly, for test class also it will provide default constructor, that is test, no arg. But here there are no instance variables for test class, no. That's why empty. Only that code is not there in the default constructor because there are no instance variables for this class test. Like that, each and every class is compiled by the compiler, and during the compilation time, if that particular class is not having any constructor, then compiler will add default constructor for that class. Like that, all these 4 classes are compiled by the compiler during the compilation time when you compile using Java C test.java. And for all these 4 classes, .class files are created. They are manager.class, accountant.class, attender.class, and test.class. Okay. After that, we have to execute only test.class file because in the test class we have main method. That's why when you want to execute which .class file is executed by the JVM is, we should write this only. If you write the above 3 .class file during the execution time, you will get error because main method is not there in the above 3 classes. That's why during the execution time, write Java test. Java test is nothing but test.class file is executed by JVM. JVM knows only .class files. Okay. Now the JVM will start executing test.class file. We are assuming that actually it is not .class file, but we are assuming that it is a .class file which is executed by the JVM. Now JVM will start from the main method of test class. So here, now I will explain this statement. So I have created object for manager class, that is manager M1 is equal to new manager. This right hand side part will create object for manager class, okay, inside the memory. So inside the memory of that object, only instance variables of manager class will be stored. So what are the instance variables of manager class? So three instance variables are there, no? Employee ID, employee salary, and employee name. These are the three instance variables which are stored inside the object of the manager class. So manager class object is created with this right hand side part. After that, inside that employee name, employee number, employee ID, employee name are stored in the object, and the address of this object is stored in this variable M1. Okay. After that, these are the instance variables. Three instance variables are stored inside manager object now, but they must be assigned with some values now. Otherwise, there is no use of those instance variables. So, what are the values which are assigned to those instance variables of manager class object? Means, how do we explain? So, from this statement, already explained. This is constructor now. Manager of this no argument it means it is constructor. So, from this statement, the JVM will go to the manager class and executes the matching constructor. Here already during the compilation time, the compiler provided the default constructor. So now the JVM will execute that default constructor and which will assign the default values to all the instance variables of this manager class object. That's why inside the manager class object, employee ID is 0 and employee salary is 0.0 and employee name is null. Which order we have taken, in the same order it will assign. So here employee ID is integer, no? The default value of employee ID is 0, no? That's why in the default constructor it will assign 0 for employee ID, 0.0 F for employee salary, and employee name is this one. But why the output is like this, like that is, here we have changed the order. In get employee details, we are printing the order employee ID, then employee name, and then employee salary. But inside the object, in this order only, the values are assigned by the default constructor. Okay. Now similarly, after that, what I am doing? So here one object is created for manager and the values are assigned 0, 0.0 and null. After that, we are invoking the get employee details on the first object with M1. That's why it will go to the get employee details of manager class and it will execute this one, which will give you the output 0, null and 0.0. Like that, in the same way, this here account object is created. Again, account class default